Okay, you want to record me? Okay. Here. The more important is not me.
Okay.
The content. Yeah, but you can record whatever. Try to do the best shot. The test 3 is the two sides, and including part 1 and part 2. The part 1 are 4 questions from problem A to D. And those problems, you can submit your answers to Blackboard and for unlimited attempts before the due date. The due date of the test is Wednesday next week by 12:15 p.m. So before the due date, you can try unlimited attempts and try to get the answers, try just like we're doing the homework. And the first part take account for 60 points, and those one is response to help you to validate your starting point and of working on the part 2. And on the second page of the part 2 will be the information you have to write it up on the paper sheet and then turn it back to me. And you have to deliver that to me, to my office by the deadline. Okay. And you have to submit it in time. And here you can see the late policy is I will deduct 1 point for 1 minute late, and using my time as a standard. Then I'll have a clock in my office. Using that one as standard. I'm serious. Okay, no late. Huh?
Is that in Greenwich or Alaska time?
My time. You can turn in earlier, okay, but no late. Because here is a 1 week test. I think there should be plenty of the time. So you just work on those things. And in terms of the details, and right now we can go over the description, because right now I want to get straight and for you to get a good start with. Basically, the question is about the problems we described last time. And here we go over the contents of in the writing here, and then I will go back to the PowerPoint slide to give you what reason is that. The first one is here we detect a satellite, and with those given information, etc. And then for Brady, those are the information. The first question, part A, is based upon the detected R and B to calculate the corresponding orbit. So which means the part A is to calculate the orbital elements. The part B is to calculate the positions of the satellites 20 minutes later. And this is the calculus problem. Okay, so this is we are given the initial position and velocity, and then we given a time of flight 20 minutes, and you calculate what the position there. The part C is this. The part C is about the launching site, and here I give you the probability at the launching site. I give you the longitude, latitude, and then I give you the time. At a specific time, I ask you to calculate local sidereal time, which is the same as we did in homework. In the test 2, okay. So here, this problem is try to repeat the problem in test 2. And then for this one, for the problem D, this one is to calculate the position of the launching site at the launching time. So here that is the kind of the general, and let me turn on to the PowerPoint slide, and that will be the better ideas for the problem statement here. So that is this one. Basically, for this test, again we have done this description on Monday, and then we assign the numbers to this PowerPoint slide here. So here is the longitude side, and in the problem statement is for grading. And here I given you the longitude and latitude of this site, and that's the given information. And then I also give, at a specific point, we have detected the satellite, and which information is given by R0s and VOS. Okay, the detected information, those are the given here. And so based upon this information, part A, the first one is based upon the detected information, I'm asking you to calculate the orbital elements for the orbit of the satellite. And here I ask you to input the semi-major A, the eccentricity E, and period T for this orbit. That's part A. And part B is this. And at the specific time, for example, that would be December 11, 2015, and at 0h, 0m, and 0 seconds, we have this object detected here. Then after 20 minutes later, say from here to here, say 20 minutes later, where is the positions? Here is, I call it RQS and VQS. At this position, basically from here to here, the time of flight is 20 minutes. And I'm asking you to calculate the two information. So basically for part B, this is the calculus problem. Okay, and again, you can dig out from the old homework how to do this one. That is the calculus problem. And part C is about the full greedy. And about the full greedy, that information is here. So here is our Earth. And let me go here. This is the North Pole, and this is K. This is I, and this is J. And this is the full greedy, the longitude side here. I need you to calculate, for example, here, what is the theta? This is the theta for greedy at the time, specific time is calculate theta at for greedy at the time is December 11, 2015 and 0h 10 minutes 0 seconds. I need this local sidereal time in terms of the degree at that specific moment, because that is a time I designate here. We say after detections, for example, greedy need 10 minutes to prepare for the launching procedure to intercept the satellite. So that is a time when going to launch the satellite. So that is the information theta here you're going to calculate. And the reason why we want to calculate theta is this. Actually, here regarding to the problem D is I'm asking you to calculate. This is the radial distance for the R1, and that's going to the part D. So to calculate the radius, vectors R1 in terms of the IJK, you need information of the theta. Also, you need information of the latitude. Okay, so that's reason why here part C, you need to answer this question first. And so for the part 1, A, B, C, D, and on the blackboard, I haven't activated the blackboard yet, but I provide this partial information. For example, if you're going to ask you to calculate velocity, and then velocity has 3 components, I provide you 2 components and asking you to fill in another one. So hopefully you can benchmark the information. That'll be good? Yeah. The second part is the part 2, and those one the open questions, and I don't have solution yet. Okay, and I intend not to provide you any solution for benchmark. I want to see how you think and how you approach the problem. Okay, for this problem is this. For problem E is this. We select this time at the 0 hour 10 minutes 0 second as the launching time, and then from Fort Greely here, this is another view of the same province, and this is the orbit of the satellite, and this is the launching site, and that is the orbit for the interceptors to intercept the satellites here. For example, for the problem E, I'm asking a design scenario is this: the launching at the 12:10 a.m. on that day, and the time of flight is 10 minutes from here to here. So, which means for satellites, starting from his detection here to here is 20 minutes. So from here to here is 10 minutes. If you can read the problem statement carefully. The satellite detected at the 000, and the launching site needs 10 minutes to prepare, plus 10 more time of flight minutes. So starting from the detected until the launching site fired the interceptor to meet here actually has 20 minutes passed by after detection. So for satellites, it takes 20 minutes to here. For launching, it takes 10 minutes to here. Okay, you got it? So for problem E, if you read this carefully, then I'm asking about the information here. The first one is, here we know the R1. So if this is the center here, and this will be the R1 being calculated from part B, and this is the position we call the R2. That is about the positions of the satellites to be intercepted at that time. So this is R2. And given the time of flight, theta t, equal to 10 minutes, I'm asking you to calculate what is V1 and what is V2.
I have a question about that. So when we rendezvous with the satellite, do we just have to rendezvous with it?
Yes, wait a minute. Yes, and not yet. Let me finish this one. I know your questions. So for part E has 1, 2, 3, 4 parts. The part E, the first part, is to answer what is a V1 here. And for the second part, what is a V2? V2 is this one. And then go to the third one, refer to the definition of the data V1, and that back to your questions. Data V1 is defined by this. This is the data V1. And what is the data V1? Data V1 is the vector difference between V1 and this one. And what is this? This is the, again, on the surface, at any point on the Earth's surface, they have a speed. That is due to the rotation of the Earth. So this is the speed of the launching site due to the rotation of the Earth. So theta V1 simply is the difference of the two. Okay, so that is for the third part. For the fourth part, what's the theta V2? And then back to your questions. Theta V2 is the difference between the V2 here, and this is the velocity of the satellites. Okay, so here we take the we calculate the theta V2 here. Will that be okay? And then that is for part E. And then once we have done this one, then you simply can add the theta V1, theta V2, then that will give you certain ideas how much the fuel the consumption would be for this scenario.
What does delta V2 have to do with the fuel consumption? So does
here is for testing, so I didn't specify the applications, but here we just do the testing, we just do the numbers.
Okay.
Okay, here I said interceptor, that means we're going to strike off the satellites. But here in data V2 is kind of the rule we have to hook on to say, well, that is here I would say that for the test rule is oversimplified scenario, but you know what I mean.
Yeah.
Okay. So that is for part E, and part F, the last part, the problem F is this. We summarize all the calculation from part A to part E, and then to part F, that is the open questions, is here. By fixing the launching time at this moment, so from part A to part E, we have exercised scenario of this, taking the launching time at here, and then taking time of flight, then we can calculate the delta V. And then for problem F is this. That is on your choice. You fix the launching site, and you fix the launching time. You choose your own time of flight, repeating all the calculation for delta V. And how to do this one, I'm asking you to write up your solution strategy, your solution procedures, and computations, and then result. So from here, based upon your writing, I'll be able to evaluate how much you have learned and how you think about this method. And then furthermore, in the part F is this. Not only to describe how to approach the procedure to do this kind of calculation, but also I'm asking you what would be the minimum value of the delta V you can achieve based upon your calculation. So which means I want to know what would be the time of flight that corresponding to the minimum value of the delta V. So this is coming to the kind of the design problem. You have to try you have to give many trials and then compare the numbers and then you finalize. So here would involve any certain discussion or analysis based upon whatever the data you try to approach.
So brute force, okay?
So that is a whole problem. And then again, everything for all the 2 sites problem, the due is the December 16th, Wednesday. I made a mistake. That should be Wednesday at 12:15 p.m. And so that is the that is the time of the finishing our final exam. And for this one, unless you have any question to clarify the problems, you can ask me. But otherwise, I won't provide you any technical help. Okay. And then again, no discussion among the people. And because here is you try to earn whatever you earn. And if you find any people have a certain discussion, you can be a spy and let me know. Okay, I can deal with this one. I'm serious. I'm very, very, very serious about this one. So this will be the very good exercise, and let me to see how much you have learned from the whole these semesters. And this semester I spent quite a bit of time, particularly in the programming, to help everyone. So that is what the time I'm trying to harvest my result from you. Okay. So good. Thank you.